In the vast cosmic ocean, there is an invisible force that shapes everything we see. It holds galaxies together, bends light across the universe, and forms the very backbone of reality. Yet we cannot see it. We cannot touch it. We cannot detect it with any instrument ever built by human hands. This is the story of dark matter, the most mysterious substance in the universe. Every star, every planet, every living thing you have ever known is made of ordinary matter. Protons, neutrons, and electrons. Atoms. The stuff of chemistry and biology. But here is the shocking truth, all of this accounts for less than 5% of the universe. 5%. The rest is something else entirely. The story begins in the 1930s, when a Swiss astronomer named Fritz Zwicky was studying the Coma cluster of galaxies. He noticed something deeply strange. The galaxies in the cluster were moving far too fast. According to the laws of gravity, they should have flown apart. The visible mass simply was not enough to hold them together. So Zwicky proposed the existence of something he called dark matter. His colleagues thought he was mistaken. They were wrong. Decades later, in the 1970s, astronomer Vera Rubin was studying the rotation of spiral galaxies. She expected that stars farther from the galactic center would move slower, just like planets in our solar system. Instead, she found something astonishing. The outer stars were moving just as fast as the inner ones. It was as if some invisible mass was surrounding the galaxy, providing extra gravitational pull. This was the first concrete evidence that dark matter was real. Today, we know that every galaxy is embedded in a massive halo of dark matter. This halo extends far beyond the visible edges of the galaxy, forming a kind of gravitational scaffolding. Without dark matter, galaxies like our own Milky Way would never have formed. The ordinary matter we see is just a faint shadow of what is truly there. But what exactly is dark matter? This is one of the greatest unanswered questions in all of science. We know what it is not. It is not ordinary matter. It does not emit light, absorb light, or reflect light. It passes through everything as if it were a ghost. Trillions of dark matter particles are passing through your body right now, and you cannot feel a thing. The leading theory is that dark matter is made of some new kind of particle that has not yet been discovered. Physicists call these particles WIMPs, weakly interacting massive particles. They interact only through gravity and the weak nuclear force, making them incredibly difficult to detect. For decades, scientists have built massive underground detectors in hopes of catching a glimpse of a WIMP. So far, they have found nothing. The most famous of these experiments is the Large Underground Xenon Experiment, or LUX, located nearly a mile underground in a former gold mine in South Dakota. The rock above shields the detector from cosmic rays. The tank holds almost 1/3 of a ton of liquid xenon, waiting for a rare collision with a dark matter particle. Despite years of operation, LUX and its successor LZ have detected only silence. But silence is also a result. It tells us what dark matter is not, narrowing the possibilities with every passing year. Another candidate is the axion, an extremely light particle that was originally proposed to solve a different problem in physics. The axion was invented to explain why the strong nuclear force does not violate a symmetry called CP. It turned out that axions, if they exist, would have exactly the right properties to be dark matter. Axions would be billions of times lighter than an electron, but they could exist in such enormous numbers that they account for all the dark matter in the universe. Experiments are currently searching for axions using powerful magnetic fields, hoping to detect a faint signal as they convert into light. The Axion Dark Matter Experiment, or ADMX, uses a superconducting magnet and a resonant cavity to search for these particles. If an axion enters the cavity in the presence of the magnetic field, it should convert into a tiny amount of microwave radiation. Tuning the cavity is like tuning a radio, searching for a station whose frequency we do not know. ADMX has already ruled out a range of possible axion masses, and the search continues. But there is also a more radical possibility. What if dark matter is not made of particles at all? Some scientists have proposed that dark matter could be composed of primordial black holes, tiny black holes formed in the first moments after the Big Bang. These microscopic black holes would be invisible but would exert gravity just like any other mass. This idea has gained renewed interest in recent years, especially after the first detection of gravitational waves in 2015. Primordial black holes would have formed from density fluctuations in the early universe, collapsing under their own gravity before stars ever existed. They could range in size from a single gram to thousands of solar masses. The smallest ones would have evaporated by now through Hawking radiation, but larger ones could still be present, making up the dark matter we observe today. The search for dark matter is not just a quest for a new particle. It is a fundamental test of our understanding of physics. If dark matter turns out to be something unexpected, it could revolutionize our understanding of the universe. If we never find it, we may have to revise the laws of gravity themselves. This brings us to one of the most intriguing possibilities. A small group of physicists argue that dark matter does not exist at all. They propose that our theory of gravity is incomplete. Modified Newtonian dynamics, or MOND, suggests that gravity behaves differently at very low accelerations. This theory can explain galaxy rotation curves without any dark matter. But MOND struggles to explain other observations, such as the cosmic microwave background and the distribution of galaxies in the early universe. The battle between dark matter and modified gravity has been ongoing for decades. The majority of the scientific community favors dark matter, because it can explain a wider range of observations. But the debate is far from settled. The truth is, we simply do not know what dark matter is. Gravitational lensing provides some of the most direct evidence for dark matter. When light from a distant galaxy passes through a massive cluster, the gravity of the cluster bends the light, creating distorted arcs and multiple images. By measuring the amount of distortion, astronomers can calculate the mass of the cluster. In many cases, the visible mass accounts for only a fraction of the total. The rest must be dark matter. The Bullet Cluster is a famous example. Two galaxy clusters collided at enormous speeds. The hot gas from the collision was slowed by friction, but the dark matter passed right through, continuing onward. By mapping the gravitational lensing, astronomers could see that the mass was concentrated where the dark matter was, not where the gas was. This is considered one of the strongest pieces of evidence that dark matter is real and not just a modification of gravity. In 2025, the United Nations declared it the International Year of Quantum Science and Technology. This reflects a growing recognition that the answers to our deepest questions may lie at the intersection of quantum mechanics and cosmology. Dark matter may be the bridge between these two great fields of physics. New experiments are coming online that could finally crack the mystery. The Vera C. Rubin Observatory, equipped with the largest digital camera ever built, will soon survey the entire southern sky every few nights. Its 3,200 megapixel camera will capture an unprecedented amount of data, mapping the distribution of dark matter across billions of galaxies using gravitational lensing to see the invisible. The James Webb Space Telescope is already peering into the early universe, studying how dark matter shaped the first galaxies. Perhaps the most exciting possibility is that dark matter is part of a larger hidden world. There could be an entire dark sector of the universe, with dark atoms, dark stars, and even dark life. We would have no way of knowing, because this dark sector does not interact with our world except through gravity. It is a haunting thought. There could be an entire universe of complexity existing right alongside our own, completely invisible to us. Some physicists have even proposed that dark matter could be a form of dark fluid, a single substance that unifies dark matter and dark energy. This would be a revolutionary idea, suggesting that the universe is filled with a single exotic fluid that behaves differently at different scales. It is a beautiful and elegant theory, but it remains highly speculative. The search for dark matter is a testament to human curiosity. We are trying to understand something we cannot see, cannot touch, and cannot detect. We are following the trail of gravity alone, like detectives at a crime scene with no witnesses. It is the greatest detective story in the history of science. What makes dark matter so compelling is that it touches on the most fundamental questions. What is the universe made of? How did galaxies form? What is the fate of the cosmos? The answers to these questions are hidden in the dark. As we build more sensitive detectors and more powerful telescopes, we inch closer to the truth. The next decade could be the one in which dark matter is finally discovered. Or it could be the decade in which we learn that our understanding of gravity is fundamentally wrong. Either way, the discovery will change everything. The invisible universe is waiting to be revealed. Every night, as you look up at the stars, remember that you are seeing only the surface of reality. The true universe is far stranger, far vaster, and far more mysterious than anything we have ever imagined. The darkness is not empty. It is full of secrets. And that is the beauty of science. We do not know the answers. But we are not afraid to ask the questions. We will keep searching, keep probing, and keep pushing the boundaries of knowledge. Because the greatest discoveries are still ahead of us. The dark matter puzzle is waiting to be solved. And when it is, the universe will never look the same again.